This video is over domain of functions. Let's look at the function f of x equals square root x plus 3. And let's play around with the graph a little bit. So let's do some t-tables. So if x is negative 3 plus 3 is 0, square root of 0 is 0. If we have negative 2, we'll get square root of 1, which is 1. If we have 1, we'll get square root of 4, which is 2. If we plug in a 5, we'll get square root of 8, which in turn is 2 square root 2. This is what we call a non-graphable point. And sometimes when you do t-tables, you will get non-graphable points, whether they're fractions or radicals. Just graph the ones that are graphable, like negative 3, 0, negative 2, 1, like what we have here. Let's explore some more. So let's go negative 4. Well, this will be square root negative 1, but it's undefined. Negative 5 will give us a square root negative 2, which is also empty. Negative 6, that will be square root negative 3. Again, that's undefined. So if we graph this, so at negative 3, we're at 0. At negative 2, we're at 1. And at 1, we are at 2. So the general graph of a square root has this little arc. Okay, or if you think about it, it's kind of like half of a parabola if we extended this line here. So as you can see, the graph starts at negative 3 and goes on to the right. There is nothing to the left. So if we figured this domain algebraically, whatever we have under the square root has to be greater than or equal to 0. And we solve for x. X has to be greater than or equal to negative 3. And that's true here. If you look at your x values, nothing less than negative 3 is highlighted or graphed. If we look at negative 4, there's nothing in that line of sight. Okay, all of the graphed part is at negative 3 and greater. Okay, so that's how you can look at your domain graphically. Where does my graph start? You start at that point and go on either to positive infinity or larger numbers or negative infinity. That's it graphically. Let's look at this algebraically. So domain of functions. There are two rules. If your x is in the denominator, whatever you have in that denominator, you're going to set that equal to 0 and solve. So in this case, x can't be 0. If your x, or if you have an x value in the square root, whatever you have in the square root, which we have an x at this point, you have to set that greater than or equal to 0 and then solve for x. All else, whether you have x squared or any x to the nth power, the cubed root of x, or any odd root or any odd index of a root, anything else you have, the domain will be negative infinity to infinity or all reals. Okay, a lot of times in textbooks you'll see a bold capital R, and that states the numbers that are in the real realm or the real world or the real number system. Since we cannot print in bold, we do the double back R or a double back letter. Okay, so there's the rules. So let's go ahead and look at a few examples. So we are going to find the domain. So we have f of x equals 7 over x plus 3. Well, x is in the denominator, so x plus 3 cannot be replaced by 0. You cannot take this out and make it equal to 0. Individually with the x, if we solve for x, x cannot equal negative 3. So if we plug negative 3 in for x, we do get that 0, which would make that undefined. So our domain is just, it's more or less all real numbers except x can't equal 3. G of x equals square root of x plus 3. We have a square root, so what we have in the square root is x plus 3. It has to be greater than or equal to 0. This whole thing can be replaced by 0 or anything bigger. But let's pinpoint the x. Let's solve for x. So x has to be greater than or equal to negative 3. If negative 3 is plugged in there, we get absolute value of 0, which is 0. Anything bigger than negative 3 will give us a positive value that we can evaluate. Square root of 2x minus 3. Well, whatever you have under the square root, it has to be positive or 0. Solve for x to pinpoint exactly what x can and can't be. So x has to be greater than 3/2. If you were to graph this, that's okay if you say that's 1.5. Algebraically, 3/2 is fine. J of x equals 2x squared minus 5x plus 7. If we look at this, there's no restrictions on x. X is not in a denominator. There's no x in the square root. So we will have all reals, or negative infinity to infinity. So any x we plug in there will get an output. And then one last one I'm going to fit right here. K of x equals 5x plus 11. Again, x is not in the denominator. X is not in a square root. So we actually have all reals. Okay, so I'm going to go back up here. Here are the rules again. Denominator, square root, you have to solve for x in some way, whether it doesn't equal or it has to be greater than or equal to 0. Anything else, it's all reals.